Hello, this is Mr. Mac. Now, this is the concept video covering nth roots. Let's start off with this nth root of a. If we have something like this, then the nomenclature is the following. First of all, you got to be very sure that this number is inside that little v on the radical sign, but that number right there is called the index. And the symbol itself is a radical, and the number underneath is called the radicand. Now, what this means is we want, this symbol right here means to find the number that when used as a factor n times yields a. Let's see if I can't make this a little bit clearer by giving you an example. The cube root of 8, for example, means to find the number that when used as a factor 3 times gives you 8. Well, since 2 times 2 times 2 is 8, 2 would be the cube root of 8 because when you use 2 as a factor 3 times, you get 8. Now, the strange thing about this is there are many times more than one number that will give you the number you're looking for. For example, if you say the fourth root of 16. Now, the fourth root of 16 is 2 because 2 times 2 times 2 times 2 is 16. So when we use 2 as a factor 4 times, we get 16. But you probably realize that 2 isn't the only number that can be used as a factor 4 times to get 16. Also, negative 2 times negative 2 times negative 2 times negative 2 gives you 16. But we do not say that the fourth root of 16 is negative 2 because we define the radical symbol to mean the principal or positive root. Now, the principal root is the best root we can get in a particular situation. Now, for like the fourth root of 16, we're looking at 2 and negative 2, and we choose 2. But if you had something like the cube root of negative 27, there turn out to be 3 different cube roots, but only one of them is even real, and that one is negative 3, because negative 3 times negative 3 times negative 3 is equal to negative 27. So even though negative 3 isn't positive, it is the principal root. Now, you're probably asking yourself, well, Mr. Mac, or actually maybe you're asking me inside your head, Mr. Mac, what are the other cube roots of negative 27? Well, let's write an equation. X cubed equals negative 27. In other words, can you see that when we use x as a factor 3 times, we're getting negative 27? So this equation actually is telling us, this equation is the one that has the cube root of negative 27 as a solution. Well, if we solved it using the techniques that we've already learned, we could write this as x cubed plus 27 equals 0. But you and I both know that 27 is really 3 cubed, so we can write that as x cubed plus 3 cubed equals 27 equals 0, right? But this factors into x plus 3 times x squared minus 3x plus 9 equals 0. Now x plus 3 equals 0 gives us x equals negative 3, which is the one that we're expecting. But x squared minus 3x plus 9 equals 0 gives us x is equal to 3 plus or minus the square root of 9 minus 36 all over 2. Now 9 minus 36 is negative 27, and the square root of negative 27 is 3i square root 3, and that's still all over 2. So 3 plus or minus 3i squared 3 over 2 also can be used as a factor 3 times to get negative 27. And so you see, it makes a lot of sense to say that even though this one isn't positive, it is the principal root. It's the only one that's real. And so the radical symbol says we want the principal or the positive or principal root. And so if there's a positive one, we take that one. If there's not, we take the one that's the nicest. Of course, that's not really a mathematical definition. Now, a couple of other things to take care of before we leave this particular concept video. Let's take a look at something like the 5th root of x to the 35th. Now, what we want to know is what number can be used as a factor 5 times to get x to the 35th. Well, if we multiply x to the 7th times 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 x to the 7th, we would get x to the 35th, because 7 plus 7 is 14, plus 7 is 21, plus 7 is 28, plus 7 is 35. And when you're multiplying the base is the same, you add the exponents. So notice that when I have a power that I'm taking an nth root of, what ends up happening is that the power of the radicand ends up being divided by the power, or by the index of the radical. So the 5th root of x to the 35th is x to the 35 over 5, or x to the 7th. So when you have a power and you're taking an nth root of it, you simply divide the index into the exponent. But when you're not taking an nth root of a power, in other words, if you have, say, the 5th root of 32, then you can't just divide 32 by 5. You have to figure out what factor can be multiplied by itself 5 times to get 32, and in this case it's 2. Now, there is some help for you on the calculator, so let's just take a look at the calculator for a minute. Now, if you were to actually press the math button, notice that the 4th function is cube root. So if you press 4 and then you put in a number like 27, we both know that the cube root of 27 is 3. The calculator will tell you that. If you want a 5th root, or let's say you want a 7th root of something, let's say we want a 7th root of 128, then what you can do is press the 7, that's the index of the radical, then press the math button and take the 5th function down. Now this looks like the 7th xth root. So 7 is the x in the 7th xth root. X root of, what did we say, 128, I think we said. So you have to put your parentheses in on your own. And we all know that the 2 to the 7th is 128, so the answer is going to be 2 here. But you can get an nth root for that. Now, the calculator will give you a decimal. For example, if you ask for the 5th root of, 58, it'll tell you 2.252607878, etc. Okay, now, to convince yourself that that's really the 5th root of 58, what you could do is you could take that number, I'm just going to type ands, and raise it to the 5th power and see if you don't get 58 back. And we do. So the calculator will give you decimal approximations for roots as well, and that's nice to know. Now there's one other thing that we do need to discuss, and that's the concept of variables underneath a radical. See, now if I have something like the square root of x squared, now if I were to say that that's equal to x, that might not necessarily be true, because if x is 2, then x squared would be 4, and the square root of 4 would be 2, so it does work in that particular case, right? But if x were -2, then x squared would be -2 times -2, which is 4, and that would mean the square root of 4 is equal to 2, because remember, the radical, this symbol right here, is defined to be the principal or positive root. But 2 is not equal to -2. So what we have to do in some cases when we're taking a root is we need to put absolute values around it. In other words, what we're going to say is that the square root of x squared is the absolute value of x. See, because if you take the absolute value of -2, you do get 2, which is what we're claiming the square root of x squared is in this particular case. Now, here's the rule. Whenever the index is even and the exponent inside is even and the exponent outside is odd, then we put absolute values around that part of the factor. Let's see if I can't illustrate a couple of these. How about the fourth root of the square root of x to the 6th y to the 8th? Well, now, no, let's do not 6 and 8. Let's do x to the 12th y to the 16th. There we go. Fourth root, x to the 12th y to the 16th. Now, x to the 12th is x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. So, or 12 divided by 4 is 3. So we get x to the 3rd, y to the 4th. But now, notice the index on our radical is even. The exponent on our 12 is even, but the exponent on our answer here is odd. So we would put absolute value signs around the x cubed. Now we don't need them around the y to the 4th because this number is also even. So all three of those things has to be true. Even index, even exponent underneath the radical, odd exponent on the answer outside. When that occurs, you have to put absolute value around it. And please don't forget that. And I'll try to gently remind you on tests if you forget to do that. All right, that takes care of this concept. We're done.